Welcome back to this channel, Trusted Chemistry Solutions. In today's topic, we'll be discussing on the topic known as compounds and mixtures. Compounds and mixtures. Now, what is a compound? A compound is defined. Now, before I start or before I continue, I would like to take the both topics simultaneously such that it will be easier for differentiation or differentiating these two topics because they are somehow misinterpreted by a lot of scientists. So, permit me to share the board to two parts where I'll have the compound discussion and also the what? The mixtures. Discussed. So let me start by defining what a compound is. Compound is defined as a substance which contain two or more elements chemically combined together. This is the definition for compound. Now let's look at the definition for what? Mixtures. A mixture is a substance which contains two or more constituents physically combined together. Now, we've seen the two definitions of either that of the compounds and that of what? The mixture. Now let's look at them one after the other. A compound, we say it's a what? It's a substance which contains two or more elements chemically combined together. Now, I want us to understand that as a compounds are those substances formed when two or more elements are joined what? Together, chemically. That is to say, compounds are what? Are new substances. One of the things we must know about compound is that themselves are different from what is used in creating them. For example, let me say that when you have elements or compound like sodium chloride, for example, sodium chloride. Now this is a common salt. Now you see that what? The salt that you have, which is this, is different from what? The sodium plus what? The chlorine. The constituents here or the elements here used in creating this what? This compound is what? Sodium and what? Chlorine. But now what you have is totally different from what? The sodium and what? The chlorine. That is to say, the chemical structure or the physical structure of what? A compound is quite different from its what? Constituents. That is a great difference between a compound and a what? A mixture. What we are saying is that once a compound is formed, the reaction that makes up that compound is irreversible. Irreversible in the sense that it cannot be taken what? Back. Now you have used sodium and chlorine to form what? Sodium chloride. You cannot reverse what? Sodium and chloride to get back what? Sodium separate and what? Chlorine was separate by an ordinary chemical what? Process. Yes, they can be separated, okay, but it takes another chemical reaction, a situation whereby when we go talk about the electrochemical series, where some elements here can be what? Displaced or can be replaced. That is only when this compound or these elements can be separated from this compound. As the class goes on, I will get to show you some reactions where this thing can happen. But let me first of all also explain that of mixture. Now, what is a mixture? How is mixture different from compound? A mixture is is a substance which contains two or more constituents. Constituents physically combine together. This is chemically combined, while this is physically combined. Which means that for a mixture is is reversible. A mixture is easily reversed. While a compound is not reversible. Now let me go back to mixture. I'm just giving you difference between a compound and a mixture. Let me go back to a mixture. In a mixture, let me give you an example. When you add a cup of rice and a cup of beans together, you see that what you have is a mixture of rice and beans. That is to say, you can easily separate the rice from the mixture of rice and beans, or you can easily separate the beans from that mixture of rice and beans. So that is to say, the reaction is physical and is easily reversed. And also we must understand that in a mixture, the mixture itself still retain the characteristics of each of the constituents. The characteristics of the rice is still there. The characteristics of the beans is still is still there, but not in a compound. In a compound, the characteristics of the sodium is no longer there. Neither the characteristics of the chlorine is not also no longer there. So you see that there's a great difference between a mixture and a compound. A compound is irreversible. Look at water. H2O. You find that the characteristics of this water is no longer the characteristics of hydrogen, neither is it the characteristics of oxygen. The characteristics of sodium chloride is no longer the characteristics of sodium, neither is it the characteristics of chlorine. So in general, we get to say that the characteristics or the chemical reaction, the chemical properties of a mixture is the same as the chemical properties of each constituent in the mixture. But in that of a compound, the characteristics of a compound, the chemical properties of a compound is not the same as the chemical properties of the individual constituents. That is another clear difference between a mixture and a compound. Let's go further. As we go further, you get to talk about the method of separation that can be used in a mixture. We have different types of separation techniques, which is our next topic. Why are we having separation techniques? It's because of the fact that a mixture can be separated. easily, physically. Why a compound, it can only be separated, like I said, when you have another reaction, which, like I said, an element supersede another element in the electrochemical world series. When I'm discussing electrochemical series, you get to see how an element easily displaces another element, in turn or in the process ended up liberating a particular element from a compound. Now, when I have another element would supersede, who have more energy than sodium, as soon as sodium chloride is added to that compound or that element, that means that that element will go and displace this sodium, and then take place of the sodium, in turn liberating the sodium out of the sodium chloride. As we get to go on, we get to see that, and we get to understand more and more better the difference between a compound and a mixture. A compound is only formed according to a fixed ratio by mass of each constituent. According to a fixed ratio. In this case, the ratio of hydrogen to oxygen is 2:1. As soon as you make it 2:2 or 3:1, what you are getting is no more water. It's now a different thing altogether. So that's likewise that of for example, sodium chloride. You can see clearly here the ratio between sodium and chlorine is 1:1. As soon as you make it 2:1 or 3:2 or whatever, what you are getting is no more sodium chloride, but something else. So generally, a compound is formed as a result of a fixed ratio of combination between the constituents. But it's not like that compared to that of mixture. In a mixture, you can have as many as you want as to the combination of a mixture. For example, I want to mix salt and water. If you look at it very well, the salt is a compound, while also water is also a compound. So that is why I did not use the word mixture of two or more elements physically combined together. What I use is two or more constituents. That is to say, the constituents can be anything. The constituents can be anything. In this case, when you talk about salt and water, the constituent there is a compound and another compound. It can be a compound and an element. It can be a compound and something else. It can be an element and another element. But they are physically combined in such a way that each constituent, you can see that even when you have salt and water mixed together as two compounds, the constituent of salt can also be removed from the constituent of salt and water. So you must understand that it's not always the case that it must be element and element. It can be a compound and another compound. But the idea of a mixture is that can this constituent be separated? Yes. If yes, then that thing that you have is not a compound but a mixture. But if this constituent cannot be separated, that is to say that what you have is a compound. So that of the mixture, the constituents do not have a fixed ratio for the combination. The number of cups for water, the amount of water can be increased to dilute that, to dissolve salt. Or the amount of salt can also be increased in the solution of salt and water. Let's look at some examples or situations where a compound is being broken down, or the elements in the compound are being displaced to liberate a particular element in a compound. Because when we say that these things are not easily destroyed, or these things are not easily broken, or they are irreversible, I want to let us know that there are some cases where during a chemical reaction, elements can be displaced. I'll give you a few examples so you have a pure understanding why and when an element can be displaced in a what? In a compound. Number one example is this. Let's look at copper 2 salts and zinc. Let's look at that one. Let's look at copper 2 salts with what? A zinc. You will see that the copper will be displaced. The copper will be displaced. How is it displaced? That is to say that zinc will displace who? Copper. You see clearly here that what? In this reaction, copper has been displaced by who? By zinc. That is because in the electrochemical series, copper is what? Having less energy than what? Chlorine, than zinc, please. So zinc is electropositive, while also what? Copper is also what? Positive. So you can see that in the electropositive series, zinc is ahead of what? Copper. And copper 2 salt is what? Is a compound. It's a compound because copper is what? Is chemically bonded with what? The sulfate. So that is to say that what? This is a compound, and you have seen that what? In some cases like this, the compound, the element or the constituents of the compound is liberated. Another example is, now look at the next one. Hydrogen what? Sulfide. Reacting with what? Bromine. You can see that what? Sulfur has been what? Liberated. Sulfur has been removed. You can see that sulfur here is solid, and while this one is what? A gas. Here also, copper is solid, while what? The zinc sulfate is what? Is an aqueous what? In an aqueous form. So you can see clearly here that also bromine has what? Displaced what? Sulfur. That is also because in the electrochemical series, bromine is what? Bromine is what? Is higher than what? Sulfur. Look at what? Carbon plus what? Zinc what? Oxide. You see clearly here, zinc has been what? Displaced. Zinc has been removed from what? Zinc what? Oxide to give you carbon 4 oxide and zinc. So you can see that in these are the cases or some cases how what? Elements can be what? Displaced or liberated from their what? From their compound in the what? In a chemical what? Reaction. So have at the back of your mind that this is how it can be what? Possible to remove or separate elements from their what? Compound. Please, I know this you found this very interesting. Please subscribe to this channel, like the channel, comment where necessary, and also share. You never can tell who you are helping. A lot of students do not have these foundations in what? In chemistry or in science. Help them so that they can help our future. Thank you, and we meet again in our next episode.